Hi, I'm going to be doing a description of the code I wrote for my Ludum Dare game, The Wrath of Gandhi. This game was made in 48 hours for the 33rd Ludum Dare Game Jam. Let's get started looking at the code. So I wrote my game on Windows in C++ and used my custom game engine that I've been developing with my friend and business partner for who knows how long at this point. Game engine does 2D, 3D, sound, like all the things you need to do for making games. But one interesting feature is it is very platform agnostic. We cross compile to Android, to Linux, to Mac, to everything. But the main one I use for Ludum Dare is a compilation to the web via the Emscripten project. So nice thing is I can make this game, build it via Emscripten, and publish it to the web in a few minutes and get people to play test while I'm even working in the 48-hour jam. It's so awesome. I highly recommend anyone who is motivated, check out Emscripten. It's a good project. So another weird thing that I do with my games is I tend to use very few source files. A lot of people learn to highly partition their code with a lot of source files, but for game jams and most of my code in general, I try to use as few source files as possible. I feel like the barriers it causes between your code and the burden it puts on header files and organization outweighs the benefits it gains in terms of extra code organization. My code organization, I find myself just like using find in files and Visual Assist F12 or go to function go to definition type things all the time. Anyway, I end up not really caring what file it's in, and so we're going to be working through the file that is the game. Won't go too much into the engine code. I'll just assume that draw a rectangle is something everybody understands, and that things like that the engine takes care of. I want to talk about how I made this game for this game jam. So the first thing that gets called in the game code is this game setup call interface. And what that's basically doing at the very, very, very beginning of the execution, it calls into the game code to set up what's this game, what's it trying to do. We can check real quick when this callback is made, and it's called in Windows. You can see right at the beginning of init instance. So right at the beginning. We've just barely parsed the command line, and now we're calling back in. So before we've created any windows, before we've done anything, we're already into our game code to set up the parameters we need to start to make the game. Some of these include, you can see right here, the height and width of the window. So when the window gets created in a few moments, we know how big to make it. The main thing this does is register this callback structure to get the major functions for the game: the init, the update, the draw, a function to handle input messages directly, and a function to clean up things when we're done. I'm just going to jump right into these functions. I quickly get out of C++ land because there's a few things I don't like about having my functions tied to classes that this class's job is to register functions, it's not to run the game. This is the function that needs to initialize the game. At the start of this function, I set some effectively global variables. This is the game I made is a hex grid game, and I need to know how big the hexes are. And when I started, I just looked at the size of the texture. I played with a few sizes for hexes, and I didn't want to update my code every time I tried a new size, so I just read it directly and I put it into this basically global constant It's not constant because it's initialized at the very, very first thing in the game, but it's effectively constant. A little bit later, I realized that I don't, the tile size is not enough. The important feature is actually how much horizontal and vertical space each tile represents, and the texture size of a hex is a little bit taller than that. I made a little picture to show this. Like when you go over a column, you actually do go the whole texture width. Like one hex to the next is actually exactly equal to one hex width of the this width of the hex is equal to the width of the texture. But when you go down, the amount you go down is from the center to the center of the tile, and that's a little bit less because of these peaks and or troughs, depending on which side you're on, of the hex. So that's just another number that I needed to type in eventually. You can't get it from the hex size. So that's what that is doing. After that, we start initializing the game and the board. One thing I like to do when I write code is have all my structures be validly initialized when they're mem set to 0. So you can see this. So that's what I'm doing. There's two major structures in the code that hold all the data for the game. The G-game structure and the G-player structure. And like I said, I mem set them to 0, and all my data contained in is valid if it's mem set to 0. You note that means that a lot of structures and classes you might be used to using, like things like the standard template library, or anything that has a non-trivial constructor, wouldn't work under like this. This is a very kind of C-style way of initializing data, and that's what I prefer. Like, this makes it, for me, much more cleaner on what you're getting when you have an uninitialized piece of, or a newly initialized piece of data, and it makes it just so much easier to clean things up when you're done. You don't get the RAI type things, but those in my game are handled in a different way. And I'll get into those when they come up. The reason there's two structures, G-game and G-player, is organizationally I tend to, even at the very beginning, start thinking about what data represents the save state, like the actual like game state for the player, versus what's like just extra data that I need to like draw or interpolate a location of a bitmap or something. And the structs I use for that is the player holds the like save state of the player, and the game holds everything else. So turns out in this game I didn't quite get to doing or needing save games. It's normally pretty easy. It's probably like 10 minutes of work, but it's 10 minutes I didn't bother to do because the game didn't really need it. So let's get on with initializing the board. So to initialize the board, I use a noise function. I'll try to pull up real quick. There's this guy that makes these awesome blog posts about games. Maybe I can find it. There was one on noise functions for map generation. This is basically, it's less useful than I thought it would, but check out this guy's site. He has got a zillion awesome tools and techniques for making cool maps, and that's exactly what I did for this game. Is I used a noise function to make a map. Basically what that means for this game is the noise function outputs a number somewhere between 0 and 1, and I partition that so that some percentage goes to becomes different types of tiles. So if this is my function, it looks something like this. And then right here, I say if the sample that I get at a particular position is less than negative 0.5. Oh, sorry, it goes from negative 1 to 1. I screwed that up while I was doing this too. If it's less than negative 0.5, it becomes ocean. So if we look and drew a line here, all this stuff would be tiles that are the ocean. And this is like a 1D representation. This noise function is 2D function, but you can imagine this kind of projected into 2D, and you get these like areas rather than these little line widths of ocean. So this is all ocean. Then the next thing I do after that, if it's less than 0.5, I go into this bracket. So somewhere around here is, this is ocean. This is something else that we'll talk about in a second. If it's a little bit higher, this part is hills, and the top part is mountains. So you can see the very top part, these little central regions will be mountains. The area surrounding the mountains will be hills, and then what's going on in the middle? Middle is a little bit more complicated. The middle has 3 possible cases. Cases are plains, forest, and grass. And what I did for that was this is all plains, forest, or grass, and then I decided that I wanted it highly random within that, but a little bit clumped, whether it's forest, grass, or plains. And the way I did that is I just took the next significant digit in the noise function and split it up so that in here, banded basically every tenth of this area. That's not 10, but you can kind of get the idea. Then 25% of that is forest, so this part is forest, like right here, 25%. Then 50% is plains here, and then the last little bit is grass. So that's how that's divvied up. We get these bands of repeating grass tile, grass, plains, forest, grass, plain, forest, grass, plain, forest. Once that's all done, we get hills up here. Once that's done, we get mountains, and on the other side we get ocean. And I'll show you real quick about what that makes. Looks something like this. This isn't quite the render that I ended up using. I'll talk about that in a second, but you can see this top little area is all mountains surrounded by some hills, surrounded by basically random plains and grass and forest in these little repeating clumps all around. So that's the tiles. Oops, that's something. So that's the tiles themselves. Next thing I do is initialize the player. The player starts with a few resources. This game is a kind of a civilization resource game, like in Civ, you have food, production, and population, and we just start the player with a little bit of that. And then we choose the player position. In this game, you always start at this particular coordinate. I just started at one that was a little bit in the middle of the board. And got to make sure that that tile is a grass or a plains, and I want you starting on the water or in the mountains or in other invalid tiles. I reveal 4 tiles around, go into that in a second, and I move the camera to this particular coordinate. As you can see here, the board is a scrolling hex board, and the camera position is a position, an offset that tells basically what pixel this upper left-hand corner is. You can see that the tiles that are revealed, this is that 10, 15 center tile, and then we revealed radius. I decided this is 4, this is radius 0, this is 1, 2. It's a little bit arbitrary whether you choose this is radius 1 or this is radius 1. I chose this. And yeah, and it's not an ocean or a whatever tile. I'll finish this off real quick. Then we generate, in this game you play as Gandhi, and your goal is to eliminate the enemy civilizations, and I choose those civilizations scattered about the map. There's a little bit of logic to that. That logic is trying to spread them out evenly over the board. So how I do that is I choose a random position, and I chose towards the end to not put it at the very last row or column. You can see this +1 and this minus extra 1 on the board width and height to put it inset 1 from the actual board width. I choose that tile. I make sure it's not a valid, or it's a valid tile. That it's not oceans or mountains or forests or craters. I make sure that the distance between this coordinate and all the already chosen enemy positions is greater than 8. If I don't, I just skip it. Or excuse me, this position and the player's start coordinate, so it must be 8 away from the player, and then I check all the other enemy positions, and then I do these complicated logic double breaks to get out, and then I actually go and place the building and the tile. So here's the tile. It's looked up by its X and Y coordinate in the board, player's tiles, set it to the palace. And I set a variable that says how many enemies are remaining, and there's 5 in this game. That's that. If there's a lot of complicated logic here, when I did it the first time, I just did these simple little go-tos. Like, sometimes when you're doing these quick games and I find it's easiest to just write the most obvious logic because it's probably going to change 15, 20 minutes later. But turns out the go-tos didn't compile in Scriptin to JavaScript correctly, so I had to actually do the fall through flags logic, which is actually surprisingly complex when it was actually really simple with go-tos to understand what was going on here. Kind of funny. Anyway, both these functions return a success condition, and for this, if anything doesn't have success, it chooses again. It re-rolls a new random seed, uses this noise function, it reseeds the noise function, and rolls an entire board. Could this possibly fail? I just did a bunch of tests, and it never fails, and it doesn't seem to even be close to failing. You notice in here I have a little test to try 1,000 different positions before you say you can't generate positions. This never even came close to failing. So for Game Jam, that was good enough for me. Even doing this repeat, I don't think I ever hit either of these actually failing. Or excuse me, I hit this one failing, but I never hit the enemy position failing. So it's a little bit of paranoia, but so far nobody's reported the game not launching. Okay, so that's now the board set up. Everything's ready to go. Let's real quick look at that reveal tiles function. That's the only thing I didn't do. We have the board, we have the tiles. These are the tiles revealed. This starts down a path of what was my error of this game. So with the hex game, the typical operations you do are a little bit more complicated than you would with a square rectilinear board game. The biggest one is give me all the tiles in a radius about a coordinate. I had this hex library that was basically again based off that guy Amit's webpage, but one function I needed is the get all tiles in the radius function, and the way I'd implemented it for the previous project was as a function callback. So it's hex range takes, didn't even have this at the time, but a coordinate and a radius and a function to call for each coordinate. And you can kind of see how that works in hex range. Here it is, and there's a little bit of this is kind of the complication of doing this iteration. I don't want to really go into it, but you can look it up on Amit's webpage. And then it calls back the function with the coordinate. This barely works. for reveal tiles, it happens to work just great because all you do is you go in and for each tile, you call this function, you get the coordinate, you turn it into a player index, and you set the revealed bit on that tile to true. Really easy. We'll see shortly how this hex range function is completely inadequate, and those of you that know a bit about kind of these more generic programming techniques already probably can see the future. Okay, so we have this game board initted. One thing you might be wondering right now is like, what? You didn't create any like drawables or some, models or some like how is this going to even show up on the screen? I haven't done anything. All I've done is filled out effectively this structure with some numbers. In fact, most of them were just set to 0. So like there's a zillion things set to 0. Like all these resources counts are set to 0 except the few I set to 10. All, the amount of research, everything's set to 0. This is set to 5. Tiles are filled up with different types based on the noise. A couple palaces drop down. How is this going to even show up in the world? Let's just go into that next. So the way I make games is with 3 functions, init, update, and draw. And draw looks at the game state, draws it. That's what it does. Every single frame. It's very simple function to write. It gets very long. It does a lot of different things to draw all the different things, but it's very easy to understand. And I want to emphasize this a little bit with just a few more sentences. Like, it is so awesome when you don't have to have separate state for all your drawables or your whatever. You don't have to create and destroy them. Your game state can be immediately reflected in the visuals by just a function that iterates over that data and does something with it. Let's describe real quick how the game does that. So, first thing the game does, it calls a render target clear. So it clears the current render target is the screen. When you come into the draw function, if you don't do anything else, clears it to blue. Next thing I did, this function is there's a matrix that gets applied to every 2D draw call in our engine, and what I ended up doing was manipulate that matrix to double the size of every pixel drawn when I'm drawing the map. So you can see I set it to like this crazy thing here, and then I set it back to identity here, and in between I draw the map. And that basically doubles the size of the map tiles. So if we open like a map tile here, you won't be able to see it, but actually you might be able to. Like, these tiles are actually half the size of how they're rendered here. And so I can make the art in, I don't know, half the time, I don't know, but like at half the resolution with and I get the big blocky pixels here. I'm going to fix this really quick because it's annoying me. The default sprite render shader that the sprite draw functions use does bilinear filtering, and to get that blocky pixel look, you need to make it do nearest neighbor sampling, and I didn't change that, or didn't. The easiest way to do it in our code base, is I just did it for the jam. I just set these 2 variables, but since in our code base, this is like the how to draw sprites is a fundamental engine feature, and yes, nice, much better. The nice blocky pixels. You can see it's an engine feature. I didn't want to pollute all the other projects that are using the engine. If this were not a jam, I would make a separate shader that drew with this blocky pixel technique, and I would update. And what's this? Something's up there. I would make that blocky pixel shader the default for the sprites, but I just didn't bother doing it. It was easier to change those 10 characters and move on with life. Okay, so now we're drawing blocky double-sized pixels with this matrix, let's go into the map draw and see what it does. When I started the game, I expected, again, to match Civ and have a horizontally wrapping board so that if you went off, all the way to the left, you'd end up coming around on the right, just like Civ does. I ended up not doing that. If you look at the game, it actually, ends over here at one side and ends over here at one side, and I just let that go. It wasn't ever important enough feature to do that wrapping. So no wrapping. But that's what this function was going to do. In fact, it started to doing it. So it turns where the camera position, that upper left-hand corner is, into the bounds of the hexes to draw. So these are the hexes to draw. It's got to draw from hex, 0, comma, from the upper right hex to the lower left hex, and it draws it with offset determined here. And these aren't even set because I didn't do them because I didn't do the wrapping. All right. Once those are gotten, we draw those tiles. In theory, if I'd done the wrap, I could have done this. That was my plan at the beginning, but I didn't do it. Do the wrapping. Draw tiles is really simple. Iterate through them all. Compute where to draw the tile from that coordinate. Look up what the tile is. Draw it. This is not even that complicated, but a little bit. Again, you figure out where to draw. The drawing function I like to use in our codebase, we have a zillion, but the one I like to use is an aligned rectangle draw. And for this particular case, I just needed the center of that rectangle, so I make a rectangle, the tile size in the center. If it's not revealed, so it's one of those dark squares, I draw the empty texture. Otherwise, I draw a texture based on the type. Here's how I get that type. Oh yeah, this is slightly interesting. This is how I do all the data in my games, both for Ludum Dare almost for sure, and even the games I make professionally. I try to keep as much data in C++ as possible. It means it just makes your data more robust, more convenient to be mutated when you need to add fields or do other things. So when your data is simple and can be kept in C++, I like to keep it in C++. So, and here's the data that represents a tile. A tile is a combination of its type, just an enum value, the texture that represent it, and turns out I need a string to draw a tooltip type thing. The way I get that data for game jams is I just make the tile array match the index of the enum. I assert that here so that it doesn't get messed up if you accidentally put these out of order. But man, this is like, if on my top 5 features I wish C or C++ added, it is, let me just store some extra data with an enum so I can get it, so I don't have to have this slightly unsafe data lookup scheme. I don't really want to iterate through this and compare. That turns something that should be instant into a slightly slow. It never actually matters, but I just feel bad about it whenever it happens. So anyway, this is how I get that texture. I draw it, and then get the building. The tile could have a building on that same tile, and if there is a building, like if this is done, this happens to return null, and if it has one, I draw it. That's it. That's how I draw tiles. So we've drawn all the tiles. Cool. Now we're going to get into, that's basically how I started the game, and as the game went on and I got more and more complicated things going on, I added more and more pieces to this draw function. this looks, this is way farther along in the game, 40 hours after I'd made the draw tiles function, I came back and said, oh, I need to handle this diplomacy drawing stuff. What does that mean? And I'll show you real quickly what that means visually so you get a sense of what's going on. I'll cheat. Later in the game, you get to a civilization and you start interacting with them and you blow them up. So the blow up effect happens on the board. I'll quickly show that. Boom, a giant explosion. So this explosion is drawn on the board, and that's all this does. I needed to draw explosion on the board. I said if I need to draw the explosion, I draw the explosion. That's all it is. There's no object that represents it. There's no stateful data I got to deal with. I just ask the question, do I need to draw the explosion? Here's that query. I say, where do I draw it? The diplomacies. This is the coordinate of the palace that was clicked on. This is that rect again. The explosion graphic is a little awkward because it. I'll show you real quick. The explosion graphic isn't really centered anywhere. It's kind of just like here is the center. And that happens to look pretty good if you just bottom align it and move it up about 30 pixels. That looks pretty good. So that's what this is doing. It's really easy. A couple lines of code and I have my explosion in the game. This chunk of code. This is the code for drawing the selected building. So when a building is selected, when you're playing, you have to modify the map as your cursor moves around. So this is if you have a selected building and you can pay its cost, so it's like if I can't pay the cost, this is selected, I don't draw anything, so I just don't do anything. If I can pay the cost, I have to do a lot more work as I move my cursor around. So if the building's selected and I can pay my costs and I'm over the map, that's what this is. Every frame the mouse cursor is translated into what I call a hit result, like you do hit test versus all the stuff in all the stuff in the game. My cursor is over the map. I get the coordinate it was over. I turn it into a tile. I look it up. If it's revealed, I draw something. If it's not revealed, I don't draw anything. I don't do anything. But if it's revealed, I start drawing some things. What do I draw? I convert that to a pixel, and I get the texture for the building. I set the building you can see is drawing at half alpha. I get the rectangle for that tile, and then I ask the question, like, can I actually place the tile there? It's either yes or no, and that's a function you can go into. It's pretty easy, pretty simple. It's like, well, I can't build a farm on the mountains. I can't build it on water. I can't build it on forests. I can only build it on plains or hills there. If I can't place it, then I use the no texture. The no texture is that red hex, and otherwise I use the OK texture. And then if I can place it, I need to draw. I want to draw the outline of the regions that are tiles that building interacts with. So like this farms these 5 tiles, the one it's over and the 4 that you can see outlined by the yellow. How did I do that? Well, this is kind of a nifty little trick. I just took this outline texture, nothing special, and I just draw it for all the tiles that I'm using, and then I go ahead and draw those tiles right on top of it, and that makes this nice little outline. It's pretty cool. And that's summarized by, like, this function draws the outline texture in, and then this function draws the tile. So that's kind of a neat draws those same tiles right on top of them. You can start to see that this is a little bit of kooky scheme for drawing the tiles. I had to like write two whole different functions to do something very slightly different. You know, like this one draws at the hex coordinate this texture hex outline, and the exact same logic is used to determine which tiles to draw. Like this is the exact same code as this, except it uses the tile, like it draws the whole tile. So like this code is identical and copied. And in game jams, I don't mind it at all. Honestly, in making games, I don't mind that at all. Copying and pasting code is something I do all the time, and I leave it. Normally I copy it like once or twice, and then at some point, if it gets annoying, I'll try to figure out a way to refactor it and compress it into something that shares the code. But normally what happens is you start a project, a new function, a new feature, and it starts out very close and very similar to something you already have because you haven't put a lot of thought into it. It hasn't developed very much. And I find things diverge over time more often than they converge over time. So that you copy, it starts the same, and a few minutes, hours, days later, it's probably completely different. And so any work you would have done to like share that code preemptively normally just makes it harder to do, you know, the feature as you figure out what things you want in the feature. So this one happened to stay kind of the same, but it's still a little different. You know, the internal function here is a little bit different, and it never came up again. So that's where it went. Then of course it draws the building with that half alpha we calculated up here. We draw the tile and then the building. This actually might be, oh yeah, you have to draw it if you you draw the background texture, the green or the red, then you draw the building on top of it. Okay, so that's all this stuff going on. Let's see what's going on here. If you can't place the tile or the tile's not revealed, you don't draw. But otherwise, we need to draw the deltas. The deltas are this little tooltippy +5 corn, you know, that's flying over here. And turns out when you do multiple of these, I draw deltas over all the different, all the different things that are, all the different buildings that are affected by the change in game state. And that's it. I go through, I compute all the deltas, every single frame, every single draw, I compute them, and then I draw them. This compute deltas function is one of the worst in the game, but we'll go into it. Let's do the draw quick first so we get, see, because we're in the mood of drawing, and it is, again, really simple, really straightforward. Calculate the pixel, we move it up to, you know, a bit to be above the hex. We talk about this in a second. We use this greenish color if it's a positive change. If it's a negative change, we turn it to the reddish color. We compose a string from this data using a printf style function, and then we draw these rects that surround that number and the icon. This draw rect stroked is kind of like mimics the Photoshop stroke function. It says draw this rect with a stroke of this width of this color, and the stroke is this color. It's really simple. And then drawstring fancy. Drawstring fancy is our most powerful, weirdest string draw function, and basically it takes a string that has some markup tags and allows you to like draw draw things, do bold. It allows you to do pagination or recentering or offsets or whatever. But the big thing for this one is I want to draw these little icons, this little food icon, this little corn thing. And so that's what this table is. This table is the representation of all those icons. And so like that food icon, you'd get a string that looks something, something like, +1, food. And that's the string. This drawstring fancy parses this. Whenever it sees this control character, it starts to look up this field, or this entry in this table, draws that icon, offset 2 down at this scale with this overall color, etc., etc. And that's exactly what this is doing. This is saying plus, or if it's minus, it just uses the, digit or decimal to string automatic. We'll put the minus in there. And this function right here is again another little, this didn't end up in a data table, but probably should, could have ended up in a data table, but little switch statement to turn the resource type into the little markup string. Draw it. We're done. That's how we draw it. Okay. Since we're almost done, I'll just quickly end all the drawings, and then we'll go back and do the compute deltas. Now we jump out, like if we're not placing a building, but it's an active tile, and the active tile, I'll place this real quick. This is the active tile. This is a tile that we selected. We can see over in there in the corner what type of tile it is. We need to draw this outline. That's all we do. Really simple. We just draw the outline. So if we've selected the tile, we draw that little outline. All right, compute deltas. Let's dive into it. Compute deltas is an interesting function because it computes the answer to the question, how much stuff do I get if I put this down? So the way I ended up implementing this is I wrote 2 functions. One that calculates from just the coordinate and the building type what it would do change to the board, and then I have another function for all the tiles nearby, see if any of them changed if I changed the board by adding this new tile, but I didn't actually add it. You probably could have done this a zillion different ways. You could have maybe put it there, computed some deltas, removed it, something like that, copied the board state, put it there, compute it. I don't know. This is what I end up doing. Let's look at compute new building delta. Why is it called a delta? Because at the time I thought these buildings would be making potentially changing multiple fields. Like you could imagine the farm only gives food, but you could imagine, I don't know, the barn gives food and production. So I kind of encapsulated in this idea of a delta. A delta is a resource and an amount of change and the position it changed at. For the new building, it's relatively simple. Each building type, you just add the things that it changes. So like the house doesn't even look at the world to decide what it changes. It always just adds 1 population per second to your total. The farm counts the nearby plains and counts the nearby grass, adds them together, and changes the food by that much. This gets a little bit, this ended up not getting as complicated as I expected, and everything ended up only doing changing one thing. A little over-engineered there. The smith, though, counts the nearby forge buildings, multiplies it by 20, and says it changes that much production. Okay, that's pretty easy for the new building function. Count nearby is a little interesting because it's the first time, instead of using just a function, we have to use a C++ functor. And If you don't know what a functor is, I don't really want to explain it because it's a mess. But the idea is sometimes you need to call a function and have some bound variables to it in a callback. So what you end up doing, you end up making a class, you stick some variables in it, you call the function in the callback, it sets the variables, and then maybe you do something with the function. So this one, you set the center and type variables, you initialize the result to 0. This is the callback function that gets called for each coordinate. This one happens to increment this result variable, and that's the answer to this count nearby function is what's stored and then out nearby. This is a total disaster. It just gets more and more complicated. It makes it really hard to reuse code between these functions. And what I should have done, if I were smarter or had thought about it more, is I probably should have just implemented this hex range function as an iterator rather than this callback scheme. But I didn't, so that's what we did. All right. This is the worst version of that function, or of that counting function, the compute deltas function. This is the one that counts all the changes for everything in range. Turns out, the maximum range of buildings turned out to be 1. I kind of put this here because I thought, oh, maybe if some buildings need to look 2 or 3 or 5 away to see how much production they make, I need to figure that out at some point. But turns out I only have to look 1 away because that's the most away a building can grab resources from in the world. So if I put this here and put this building here, this placing at this tile needs to look at every adjacent tile, finds this farm right here, and says, oh, this farm with this tile here, how much would you change? And it can get more complex here, that if I place this here, these 3 farms all change -1 if I were to place this lumber mill here. And that's what this is doing. It's saying for each coordinate around this placement coordinate of radius, turns out to be 1 because that's the maximum radius buildings have, compute the deltas. Again, it's this awful functor thing because I needed all this data to store the new building's information. And here it is. Not very complicated, but it's like basically does the same thing and computes the like how much that building would change, adds that to the deltas, returns it. Ugh, what a mess. I sum these all together, and that's the answer. Like the deltas themselves are on this list. The total number of deltas are here. We come out and we draw them. Notice, again, if I had done that like multiple deltas per building, like if it changed food, I would have had to like do something to like collate them together. So like it was +2 food, -1 production when I played. They would have been needed to be drawn together, but that never happened, so I never did it. So it's much simpler than this over-engineered function. Anyway, that's it. We're done with map draw. Next, we draw a bunch of just black panels to outline the UI. So this top and this side and this whatever, like, we don't want these hexes drawn. We want to cut them off. So we draw those 4 outline rectangles. Then we draw what I call the build menu. This thing on the left here is the build menu. It holds all these items in it. This build menu, once you get a bunch of stuff, let me see if I remember what the keys were that unlocked everything. Maybe I didn't do them. But eventually this build menu scrolls, And again, to do the cutoff, like if this was moved up a pixel or two, then I need to draw something on top of it. And so there's these two little rectangles above and below the build menu. I draw these tabs. I just call these tabs because it's like a tab control. I draw the tabs. I draw this little piece of text that says how many civilizations remain. I draw this little rect up here, which is the tooltip window, which does all this. And then I draw the resources up on the top here. We'll go in these in a second, but I'll just give you a high level, and then we'll drill down. I draw the diplomacy screen. Whoops. Draw the diplomacy screen down here at the bottom on top of all of that. I draw the dialog boxes, which is like that win dialog on top of all of that. And then I ended up I was drawing something in a cursor, but this actually doesn't do anything because nothing ended up in the cursor. But the idea was maybe if you were in this state, before you dragged it over into the world, the house could have drawn underneath your cursor over here, but that just never became important. So let's go into the major components. First, the build menu. How does the build menu drop? Again, you're probably getting the theme. It's just like you look at the state of the game and you decide what to draw, you know? Like, here, what's the state? Well, I have this selected. Oh, look at that. You know, I have the building tab selected. That's what this says. If I have the building tab selected, draw the building tab. If I have the research tab selected, draw the research tab. Not rocket science. How do I draw the building tab? Well, I iterate over all the buildings in the game. I ask the question, have you unlocked that building yet? And then, if you have, I draw it. You know, building unlock function is relatively simple, but this is where the gameplay is. Here are the rules for if building's unlocked. House is always unlocked. Farm is unlocked as soon as you build one house. Lumber is unlocked as soon as you build one farm. Outpost is locked as soon as you build 3 houses, etc., etc. Eventually you get some research, and if you've done the research, the mining, you can build the mine. Pretty simple. Let's look at the draw function. Again, most of this is just like computing rectangles and, you know, then calling the appropriate draw function. So I have to compute which where these rectangles for each of these items are. That's a function of the index here. We can look at that really quick. It is this gobbledygook of pluses, you know. So this is the important thing. It's like, you know, here are the coordinates multiplied by, or added with this number for the index of the item, and then this magic number is the slide amount of this scrolling area. Again, just like this has this slide amount camera position, this has a slide amount building menu position that gets updated when you drag. We'll get into that input and update in a little bit, but it's, you know, basically that input just changes this number, that sliding just changes that number, and then we draw things slightly differently because of that. Cool. We detect if the item is outside this area, you know, if it's scrolled and this house item were like up here in the tooltip, then don't draw it. So that's what this is saying. Anything, if the rect for the item does not overlap the rectangle of the build menu, is outside of the build menu area, don't bother drawing it. If the building is selected, then we draw this this outline thing here. You know, this yellow, or this box with this outline. So we draw that stroke rect, the inside's black, the outside's yellow. If it's not selected, So if it's not selected, but I've moused over it, I draw it with this type, with this stroke happened to end up being the same stroke. So there we go. Like here's that case. This one I can't actually build, so it doesn't get it, but this one I can build, so I get some feedback when I mouse over it. That's what that's doing. It's funny that those ended up the same rectangle. Normally, I probably would have, if I had noticed that ever, I would have made those different states, but now I didn't ever notice it. We get all that data for that building. Again, that's just like we saw before for the tile, except this is all the data for the building. Organized the same way, bunch of fields, bunch of data, done in a C-style array initialization. Compute some rectangles for where everything is, like the title's here, the count is here, the cost is here, the icon's here. Compute all those. Just, normally I lay this stuff out in Photoshop and then just translate it into code. If I can't pay it, I draw it 50% alpha, so it gets this grayed out effect. And then I just draw them using the appropriate draw functions. Here's one that allows me to scale the icon because the icon is at half size normally, but I ended up wanting it to basically match the size, so I doubled it here. I draw the name, draw the cost. This is a little bit slightly more complicated because the cost is this complex set of numbers and types and a multiplier based on how many buildings you've built already. That's what this does. It turns it, calculates the multiplier. I made this game thinking it was going to be more of an idle game, so I ended up using big integers for all the cost numbers. I don't think you could actually meaningfully play the game to the big int land, so that was kind of a mistake, or again an over engineering. And that's it. We've drawn the menu item. Same exact thing. I think we have enough. Let's draw some researchy things. Try to get to research. I thought it was. Let's get to the research state so we can see the research menu. But the research menu is almost identical to the. Oh, I need to build a school. Oh, we'll wait a few seconds. Come back to that. Research menu looks almost exactly like the build menu. It just draws the research. And again, I copied and pasted. A lot of this logic is the same. Again, if it's outside the window, don't draw it. Again, the same highlighting stuff. Different rectangles, slightly different draw routine. I need to be better at this game to get this to build faster. Here we go. Here we go. School. Now we got the research. So you can see it's almost identical. It's just a different, there's no little count thing over here. Different icon, but pretty much the same thing. Again, just copied and pasted because, they'd probably diverge if I put more time and energy into it. Buildings would get more different fields than the research would get. Draw the tabs. This is really simple. This is just drawing these two buttons with a color based on whether they're selected or not. Not rocket science. Very simple. Get the rectangles, draw them. Tooltip draw. The tooltip is this area up here. This is the most complicated state. If there's a selected building in the world, you draw the building. If this is selected, you draw the tooltip for the research. If this is selected, you draw the tooltip for the for building the thing, and it's made up of an icon, the name, this generation string, and this helper tooltip, helper text string. Whoops. This one is the name of the tile, the name of the building, the effect of the building. You can see what these are those three cases. This is when I'm drawing the building, this is when I'm drawing the research, and this is when I'm drawing the tile. Building, super simple. Get the texture, name, description, draw it. Research, same exact thing basically. Texture, name, description, draw it. The tile version, it's a little bit more complicated because you have to get the texture and the tile, and then if there's a building on top of it, get a few more things. Compute what it produces. You know, if I click on this one, it produces 6. If I click here, it produces 5. Another feature I was gonna do, but I just ran out of time and it didn't seem important enough, is do that, you know, like when I place it, I do this nifty circular, you know, outline, or this outline effect. I was gonna do that, but I just ended up not doing it. You can read it here, but it would have been, you know, kind of nice to draw the outline around the tiles that are in use by that selected tile. And that's it for the tooltip. And the resources, even simpler. You can see them at the top here. It's just an icon, 2 strings based on numbers in your game state, and so on. Like, really simple. Get the texture, get the count. You know, you can start to see, like, hopefully that this is a really easy way to draw stuff. You know, just look at the state, draw something to represent it. It makes it really easy to represent whatever you need to represent. You don't have to manage any, you know, rectangular variables and new them and delete them, or, you know, manage them in any way. You just call a function. Super stateless, super awesome, super easy. Diplomacy function is a little bit more complicated. I'll go through that now. It seems okay. Again, we'll put it up there. The only thing complicated about this one is this is a state machine. You start out in this state where you're like making the demand of the adversary. You click, you go to this state where you're drawing this slightly different thing. A few moments later, you get into this state, click the button, you're in this state, board state changes, you're back to playing the game. And that's all that we're doing here. You know, we go through, we draw the stuff we always draw, which is the background, the picture of Gandhi, the picture of the foreign ambassador. And we draw this, you know, tiny bit of text. Let's go find another one up here and go through it. Draw this face Gandhi text up at the top. You know, here are the list of all the demands that you could possibly make. If we're in the make demand state, we draw them all, you know, and format them with a little number in front of them and draw them. If we're not, we draw the one that you did select right above it. So we, you know, as soon as we click this, this moves to this spot, it loses a number, you know, and we draw that from then on. If we're in the fire missile state, this person has had their chance to speak. Now we're in the fire missile state. We draw that. There's a little bit of change to do the selection. If the hit test returns item, then we draw it red. Again, otherwise we draw it right. And look at that, we have selection. Boom. That's it. And if you remember, if we're in the explosion state, which gets triggered after we click this, we draw that explosion on the map. Simple, you know. Diplomacy. Dialogue, I think there's 2 states here. There's the title, like when you're at the title screen at the very beginning of the game, you draw this background, you draw these 2 buttons. That's basically what it is. You draw the background, you draw the play again button, you draw the music button. When you're in the win state, you draw the background, you draw the play again button. Really simple. And again, like I said, the cursor does nothing. So that's it. We've now gone through everything that's drawn in the game. You know, we've set up the board, we've drawn it. Now the only thing left to do is handle input and simulate the game. That's the third function and a little bit of this one, but mostly the update function. I'm going to quickly do the input function because here's another thing I like to do in video games. Normally in video games you have some sort of event system to deliver you the messages of like some input happened. Sometimes that's the only way to get things done. For example, the mouse wheel, turns out the mouse wheel scrolls this build menu or the research menu. The only way this kind of meaningfully works, you can kind of meaningfully get input from the mouse wheel, is to handle one of these messages and do something with it. So in this case, when you get the mouse wheel message, you decide if it's going forward or backward, figure out which tab you're on, and move the position some amount. This clamp. These two clamp functions are really simple functions that just don't let the top or bottom fall off the edge. So it's like it calculates how many items there are, and it says, okay, the top number is wherever you are, or 0. The bottom number is wherever you are, or this bot number that's calculated from the number of buildings available. That's that. Then I handle the cheat keys. Yeah, oh, no wonder I must have deleted the get infinite money button. That's funny, because normally it would have been here. Like, that's why I was pushing M all day and not getting infinite money and research options. Anyway, I handle these two cheat keys. When I submitted this, I think I just commented these out. They let me win the game immediately and reveal the board. And you can look, it's like, how did I win the game? Like, what is winning the game? It is this. It is changing the game state to win. Then that gets pulled by the draw function, and you draw that dialog on top of it. It gets utilized in the middle of the hit test function, which we'll get to in a second, to say, hey, you know, when you're in the middle of winning the game, can't click on the background, you can't do anything. The only thing you can do is hit test that play again button. You know, that's it. And the reveal function goes through every tile on the board and sets its reveal state to true. So that's all the input handling. Oh, sorry, I skipped this one at the top here. If the right mouse button is clicked, I clear the selection. And again, very simple. Set some state that says the selected things are no longer selected. That's it. So, okay, you're probably wondering, like, a lot more happens in the game than these, you know, just clearing selection, scrolling the mouse wheel, and cheat keys. How does that happen? It happens in the update function. I am a big fan of polling your input state whenever possible. This is not possible in a lot of frameworks and a lot of, you know, platforms. Like, you know, most of the world, for whatever reason, for a lot of good reasons, but has moved on to things like mouse move events and on click and this, that, and the other thing. And what I find is they just don't work. You know, I don't think I have yet to use an API that correctly matched every mouse up with every mouse down. You know, like, or excuse me, every mouse down with every mouse up. Like, invariably, something comes along, grabs away your context, and you get one without the other. And now, if that's all you did, you're stuck. You know, you're stuck always. Like, you know, if you matched your, you know, mouse down of A to start moving to the left, and mouse up of A to stop moving. You know, we've all played games where you press A, something happens, you don't even know what, and you can't not move left for the rest of the game. You know, maybe it resets itself when you press A again, maybe it never resets itself, you know, and you have to reboot the game. So for me, particularly for game jams, it is so much easier to just pull the input state whenever possible. And thankfully, our game engine, Windows, etc., you can pull the mouse position, you can pull the button state, and our engine provides the technique infrastructure to to effectively pull the key state for whatever keys. And that's what I use in the game. I use keys, I use mouse button, I use cursor position, and I pull it all the time. That's all I do. Pull, pull, pull. Alright, so let's work through the game update function. Do this, we're done. So we're almost, there's a little bit of complication here, but it's almost done. So this stuff at the top just helps is the stuff to keep track of time in the game. I do both a frame integer counter and a game age float counter. This isn't actually necessary. I don't change the frame rate of the game ever, but if I did, that's what this would do. Okay, let's do some logic. Well, what logic do we do? Well, normally I just write logic and then add more and more logic. There normally is an order dependence to the update function, but believe it or not, it often doesn't matter when you have full control over the update. If you just write your code linearly, you don't do any crazy callbacks, you don't do anything insane, do I update the diplomacy first or the resources first? Probably doesn't matter. If it does matter, you fix it later. So this ended up here. I'm updating the diplomacy first. If the diplomacy is active, if it's the response phase, the diplomacy response phase, I update this counter when that counter exceeds the duration. So after 2.5 seconds, I move the diplomacy state forward. And my diplomacy state is just this really simple enum. I start with the demands, I do the responses, the player chooses demand, the foreign ambassador makes a response, the player chooses to fire the missiles, explosion draws on the screen. That's it. So here we are. We did the response. If we're in the response phase, all we're doing is waiting 2.5 seconds for the ambassador to finish talking. And then we move on to the next state. If we're in the explosion phase, all we do is wait 2.5 seconds until the players enjoyed the explosion, and then we move on. Moving on in this case means ending diplomacy, turning all the nearby tiles to the explosion into craters, and if that happened to be the last palace, you win the game. Again, nuke terrain is this, so for each tile within one of the palace coordinate, turn that into a crater. That's all this does. All right. Then we update the tick counter. So the numbers at the top of the screen go up at some rate. I chose specifically to not have them go up continuously. They go up in these ticks. These ticks take a second. Every second, do a game tick. This is basically the simulation of the game. Simulation of the game is go through each resource and add the rate to the resource number. I'm not even sure why I put this total resource number in, but I guess I thought I was going to have something that used the total resources you've ever gotten. This is your current amount of resources, this is total resource. When you spend against this number. This number I'm just tracking for no reason because I didn't end up using it for anything. So this is the whole simulation. You just saw it. This is the whole state machine for the diplomacy. And then the major stuff of the game, it's not even that much, is clicking. What happens when you click? And that's this, the rest of the update loop. What happens when you click is the first thing we do is we pull the cursor position, and then we try to figure out with this hit test function, what did you click on? Or where is the mouse cursor right now, even if you haven't clicked? Ask the question, where is the mouse cursor? And what is the relevant thing you interacted with on the screen? Well, if you're not playing, things are a lot simpler. Either you hit the play again button or the music button. So there's actually only two game states. There's title, playing, and win. Oh, I guess this might have a bug. Now that I think about it, I should have differentiated the end game. You can click the music button on that screen. How hilarious. Because I needed to say if games, I needed to actually write this as if game state equals title. Do this. If game state equals win. Do this. Get rid of this one. And voila, we have just fixed a bug. It's that simple because I'm just bad at programming and probably just added that win thing after the game was over. So look, now we can't click this invisible button here. That's it. And I have fix whatever's causing that problem. Anyway, again, we just look up into the rect. Does this rectangle contain that position? Then we say we're over the play again button. If we're over the music button, we're over the music button. On and on. Okay, so go to the next state we could possibly in. Is diplomacy active? Okay, so let's get to that real quick to show that world. Right. Notice clicking in the board doesn't do anything. Only the highlighting down here does stuff, and that's this state. If we're in the demand state, we look for these 4 rectangles that contain the text here, and we highlight. We say you hit the text item. If we get along to the fire missile state, we have the rectangle that contains the fire missiles button. That's it. We hit a text item in those 2 states. We report it above. That's what the mouse is over during that frame. Alright, if we're not in any of these states, we're in the normal state of the game. 2 things. Whoops, I scrolled down a little bit. Here we are again. Okay, where could we be? Well, one place we could be is inside this map area. If we're in the map area, we say you hit the map, and we conveniently convert the pixel coordinate into a map coordinate. And we return it. Hit the map, this coordinate. If you're in the building tab over here, we say, or excuse me, if you're in this region here, that is the tab that sets things to building. We say you hit a tab, and that tab is the building. If you hit the research tab, you're in the research tab, and we report that out. You hit that tab. Then the build menu down here. If the active tab is build, we count how many active buildings you exist. We compute their recs. If you hit any of them, we say you hit the nth rect. You hit the 3rd or the 4th, or in this case the 2nd. I hit the 2nd item, i.e. index 1. I'm over the farm. If I'm in this state, oh, now I'm over the index 2, the lumber mill. Same thing, if we had some research, we could mouse over the research. That's it. We did hit testing. We now know exactly which part of our game the cursor is over. Now, here is the most complicated logic in the game, and it's complicated because it's doing let me put it this way. I find that this logic is complicated, but tends to need to be complicated to do complex interaction. Again, I think most people are used to a world where they get on click or mouse move or scroll bar position change or some very high level event that describes what happened. But when you have the low level, you were over this thing and the mouse was up or the mouse was down, you can very easily translate that into, okay, what actually did you want to happen? Oh, when the mouse is over the board and I mouse down, and then it moves, and then I up, well, that's a drag. You know, it didn't get translated by the system into a drag. I had to figure it out. That meant a drag. But it turns out that's relatively easy to do. And I can know that when I'm in this state, when I have the farm selected, I can know that, like, oh, you know, I can still drag in that state properly and not turn that into accidentally dropping the button. Or if I just click and don't drag, I can drop it. And you can handle all those different cases, and we'll go through them all one by one. The AND logic, the Boolean logic to determine all this stuff can get a little complex. You know, and for me, it's a kind of a little bit of a function of experience. I've done this so many times that complexity isn't actually that high because I've done it a lot of times. But I can totally see for someone that hasn't done it a bunch before, it might be hard to read and parse what's going on. But we'll try to get through it. So, again, we just did the two, whoops. Okay, oh. We just did the hit test to decide what to do. Now we're going to turn that into clicks. Okay, so again, if we're not playing, you know, if we're in one of the dialog states and the mouse was over the hit box, or the play button, so let's get into that state real quick. Okay, if the mouse is over the play button and the mouse is down, okay, so I won't do that because it'll do it. And here's a state variable that's a little complex to understand, but it's not really. Mouse was down. This is the statement. Was the mouse down previously? Like, so if I am down and I was not down, that's what a click is. A click isn't an event callback. It is the transition from not being down to being down. So I'm not down. I am down. Boom! I just jumped, and I do the click function. This click function, not that complicated. I play a click sound. I call the init, which wipes everything out again, and I choose to skip that opening menu and jump you straight into the game. If I don't do this, we'll see Gandhi again. You know, like do this, play. Oops. Did I screw something up? Oh! This is reused from both states. This is both play and play again. So, you can't do that. We don't want to skip add Gandhi to the end game because both of these shoot us right to this state. And when we get to the win, click this, we go right to this state. Again, if the music is clicked, we do the music. And the music is just kind of a little gag I did where if you want music, click it, opens a URL in your browser with some awesome music because I didn't compose any awesome music for this game. So it just opens this YouTube page with awesome music. Kind of a little gag to get music in the game without doing anything and violating the authorship rules. If the diplomacy is active, that's another state you could be in. If the diplomacy is active and my cursor is over one of these buttons and the same clicked logic happened, boom, I do the clicked. What does clicked do? Again, plays the clicked. It sets which demand was clicked. It says if you are in the state of demands, you advance the state to the next one and you set the counter to 0. If the state is in fire missiles, you play the explosion sound. You decrement the number of palaces, you advance the diplomacy state, set the counter to 0, and clear your selection. Honestly, this that's when you'll notice at the very beginning of the diplomacy, the palace is kind of in the selected state, it's outlined. It's up here. I thought that looked cool and tied you together, so I just left it. And then once you've get to the fire missiles. Once you fire missiles, it clears that selection on that tile. You can come back and select that again if you want later and see that's a crater, but I thought that was the right. That was the flow I thought was good. Again, if you hit a tab, what do? And it was clicked. boom, you set the active tab, you clear the selection, you know, because you're not, you know, if you had the house selected, you clicked it, the house is no longer selected, you know, that's what it does. And you play a little click sound. Okay, now the map. Again, kind of the most challenging thing here. It's not even that challenging. Here's the map code. If I'm on the map and the mouse wasn't down, or the mouse was already down on the map, get to that in a second, what this means, then, so let me clear this section real quick. So I clicked on the map. Okay, so I clicked on the map. If I hadn't clicked on the map, and then I clicked on the map, what happens? If the mouse wasn't down on the map, I start dragging. This is the beginning of the drag operation. I find out my position, and I set that and if I've moved a bunch, I start dragging. Okay? This flag right here effectively is capture. You know that really complicated stuff in Windows UI like focus and capture, and you can never quite understand what's going on, what do all these functions do, why does these random calls sometimes lose and gain capture, particularly complicated things like, you know, more complex controls like scroll bars and who knows what. Like, this is, for this game, this is capture. When my mouse is down on the map, you know, I've captured the mouse. I can't, you know, if I mouse up over here, I don't accidentally click this button. I've captured the mouse. I do this highlight thing. I hadn't even ever noticed that, but would have been very reasonable to come along and not do the highlight if I'm in this mouse was down on map state. That means the mouse was pressed down on the map. This has gotten capture. Nothing else should react. Probably should have gotten rid of this highlight. If I would just test this flag, not draw anything. This function is to differentiate a drag. This is drag versus a click. You know, like if I mouse down, don't move anything, and then, or if I do move, then I started dragging. If I moused up and I wasn't dragging, then if I clicked on the board, I clicked. If I clicked off the board in this area, I don't do anything because there's nothing to do. So the map can either be clicked or the selection cleared. The map is clicked, has a few states. If I click on nothing, you know, in the normal state, which is this one, I clear the selection, I set the active tile, I decide if it's a palace or not at the palace, because if it's a palace, you can see if I click on the palace, I click the palace, and I play a sound, start diplomacy, I set the initial diplomacy state, I say which palace I clicked on. Or, if I have do this real quick, or if I have a building selected, you know, and I click, then I go in here and I say building placed. What does that do? Again, sound click. I double check that I can pay the costs because I don't actually have any negative cost things going on, but you know, I don't know, maybe that was stupid, and my thought was maybe you'd play an error sound if you didn't have enough for the cost, or you pay the cost, reveal, figure out how many tiles to reveal, and reveal them. Again, that depends on what type of building. So the outpost, which we've barely talked about the game rules because there's not many game rules. You know, game rules we talked about are like that deltas function. That's a big game rules function. This one, which is how much the tiles reveal, the default is 2. If it's a outpost and it's on a hill, it reveals 3. If it's a buoy, you reveal what I call harbor style navigation, which is a little bit more complicated form of reveal. That reveal reveals it reveals all water and up to 1 unit into the coast. I'll go into that function really quickly to talk about that. The other slightly interesting, so let's just go through these one by one. Building at base cost, again, just looks up in that table. You know, here's the base cost right here. Some things have multiple components to the cost. We just handle that. That's utilized in the can pay cost function too that I didn't go into, but it's like check if you know you could pay it by comparing the resource costs to the total cost, which is the multiplier times each component. If that's all true, you can pay the cost. Yay. Again, and also can place tile. This is a bit of game logic too, just as the rules for can you place the tile on, or place the building on the appropriate tile. Buildings can't place anywhere, or non-buildings can't place anywhere. Buoys must be placed on oceans. Harbors must be placed on ocean tiles within range 1 of a non-ocean tile is what this means. So it's like on the shore. Everything else can't be placed on, you know, basically must be placed on hills, plains, or tiles, or hills, plains, or grass. The cost multiplier function is the thing that calculates, given how many buildings you have, it counts how many buildings, it computes an exponent an exponential to multiply by your base cost. I ended up doing this. I started with just doing integer exponents because that's what the big int library I had did. But I found I wanted a subdivision between 2 to the x and 1 to the x because there's a lot of room between those two. And so I did a simple rational exponent, so an exponent of a rational number is the same as an exponent of the numerator divided by the exponent of the denominator. I chose a denominator to always be 10 just to make it easy to write these things in this field or in this table. So these are the exponents, and it's effectively 1.5, 1.5, 1.5, 2.5, 2.0. Just divide by 10 there. And that's how we compute the costs, is we multiply that multiplier by the base cost and we get it. Again, the pay cost function just does that and then subtracts it from the total resources. Looks up the type. Each cost has the type and the amount, and you pay it. And you subtract it from your current resource count. Again, reveal those tiles. If you played a harbor and you have navigation, that has to do that special reveal that's kind of like the buoy. Like anything on the water reveals over the water. The navigation ability lets you see more over water, and so it's like I can see 3, and then it's again this horrible scheme that reveals ocean tiles, or this function which is tiles that are nearby the ocean that are within the radius of the reveal request, which is another insanity level functor that does that job. Never do this. It's completely unwieldy and difficult to think about and compose. Yeah. Don't do that. After we've done it, we've placed it, the next thing we have to do is compute those deltas. This is the same function we used to draw the deltas. I was gonna do a little floaty delta once you place it, but I ended up not doing that, so that does nothing. I was gonna do this thing where you got an extra bonus if you got a ring, but I ended up not doing that. If all 6 tiles neighboring you contributed, I was going to give you a bonus, but I ended up not doing that. And then I just go through and add the deltas to your current resource rates. So when you place a tile, it says +6. Guess what? You get +6 food. If it says +6 food, you get +6 food. You increment the building counts for that type so that you can see it on the screen and the cost multiplier goes up. And here it is. Now I've placed the building in the world by assigning that tile's building to be that building, and I deselect the current building because that seems like the right thing to do. That's how you place a building. Declare selection we've already talked about. Palace click was talked about. So that is what happens if you clicked. What happened if you dragged? Well, the drag code is so simple it didn't even merit a function. If you're in the dragging state, all you do is add a number, add an offset to this camera position. So like if you're drag state, you drag. If you click, you do that more complicated thing. That's that. Now, here's what happens if you click the one of the build buttons over here. Again, this has a drag capability, much like the map. If this had all the items in it, same exact logic, let you drag. This drag gets clamped. I didn't implement a clamp for the board. It actually does look kind of stupid that you can drag the board off the side here. I just didn't implement it. If I had another half an hour, not even another 5 minutes, I'd probably implement that to get rid of this ugliness here, but it never seemed important enough. It kind of gives you a cue that you're at the edge. Honestly, I'd probably drag you to here, draw something nice behind the board, and you know you're at the edge. Anyway, but this menu clamps here. Same thing with the research menu. But if you're not dragging, based on which thing you clicked on, you do the clicked thing. If you clicked on a build option, it clears the selection of what you had selected. It converts the index, so I clicked on the one indexed thing here, converts that to a building type, and says you have selected that type of building. Honestly, if I were to do this again, I would have done that in the hit test, not have to do this conversion silliness. Same thing with the research. This is the research version of that. And then, again, if we get some research showing, research items also have a little area over here to actually do the research. When you have enough research points, a little button shows up that says, go ahead and build this. And that's what this is. If I click the research, like to pay for the research, if you can pay for it, you pay that research cost. And the only thing that happens when you set the research to be researched, and the one thing that happens when you research is if you research the navigation function, we go and for each harbor, we do the reveal of the harbor, because the navigation research is harbors can see a little bit farther, so we make them reveal a little bit farther. That's it. That's all the map click functions. If you click anywhere else, this is, again, remember, this is a click. A click happened. If you click anywhere else, we clear the selection. This is the logic that stores that the mouse was or was not down that previous frame. We just assign it to a variable. And then based on what happened with the hit test, we turn the hand to, or the arrow to a hand or back again. So if we hit nothing and the mouse was down on the map, and was not down on the map, if we hit nothing and the mouse wasn't down on the map, we draw a hand, we draw an arrow. If we hit a build button but it's not active, in this case, we draw the arrow. Every other case, we draw a hand. So we draw a hand when we're dragging, we draw a hand when we're dragging, we draw a hand when we're over buttons, we draw a hand when we're over, tiles, when we're over the world. So we draw a hand when we can do something, and we draw an arrow when we don't. And if we change the logic, we just change that logic. And that's it. We handled, for the update function. It's this tiny bit of simulation, a whole bunch of logic that's mostly determining whether you clicked or whether you dragged, the few handlers for those cases, and a little bit of state machine ticking. That, plus the initialization, plus the draw, is the entire game. Went a little longer than I hoped, but this is how I make a game in 48 hours, code-wise. People are interested, maybe I'll do an art version of this too, but I hope you enjoyed this. I hope maybe you learned something, maybe you learned, or just saw a different way of doing things, or maybe your way of, happy to see some of your ways of doing things represented here as well. Thanks so much for watching, and if you have any feedback, let me know. You can tweet me at Graysphere on Twitter. So thanks again.